Let's sketch a rational function. So this one starts out nice and factored for us. And what we're going to do is collect a bunch of information, y-intercept, x-intercepts, vertical asymptotes, horizontal asymptotes, collect all this information and then put it together into a nice graph. Most of this information isn't that difficult to actually collect. You just have to take your time and work through it. So first of all, our y-intercept. Y-intercepts always occur when x equals 0. So let's substitute a 0 in for each of our x's. Let's evaluate this function at 0. So we have 2 times 0 minus 1 squared times 0 minus 3 in our denominator. A little bit of simplifying down here. Hopefully we're okay with saying this is 2 squared, which will be 4 times negative 2 will make negative 8. Over, let me see, this is 2, and then negative 1 squared is going to be 1. So 2 times 1 is 2, times negative 3 is going to be negative 6. Or with a little simplifying down, we can say that's 4/3. Or for an approximation on our graph, let's use 1.3 approximately as far as putting a point on our graph. Okay, next up, let's think about x-intercepts. X-intercepts in general occur whenever the numerator equals 0. And since ours is factored, this is actually pretty nice. It's going to save us some time from having to do the factoring ourselves. The numerator is going to equal 0 when we plug in a negative 2 for this first factor or a positive 2 for the second factor. Sometimes we refer to these as zeros as well as x-intercepts or roots. So we said negative 2 and then positive 2 based on these factors. Next up, let's pick up their multiplicities. So multiplicities are based on the exponents that each one of those factors is raised to. So the negative 2 came from the first factor. Its multiplicity is going to be a 2. The positive 2 came from the second factor. We'd say it's raised to the first power, so its multiplicity is going to be 1. Finally, let's talk about whether they touch or cross. Now, this is based on the multiplicity. Even multiplicities touch and stay on the same side of the x-axis. Odd multiplicities cross to the other side of the x-axis. Next, let's find vertical asymptotes. Now, vertical asymptotes in general occur whenever the denominator equals 0. Now, there is the off chance that we could have a removable discontinuity or hole in the graph. Those occur whenever you have the same factor between numerator and denominator, and you would be able to put this into lowest terms by simplifying and canceling out one of those common factors. That's not the case on this one. We don't have any common factors between numerator and denominator. So any of these that we locate are actually going to be vertical asymptotes from the denominator. Okay, so what we want to do is kind of look at the factor by factor. Now the 2 is not going to contribute to any vertical asymptotes, but this factor that has the x with it, the x minus 1 quantity squared, that's going to give us a vertical asymptote at x equals 1. Just kind of visualize what would you plug in for this x to make this factor equal 0. Similarly, over here for our x minus 3, we could say that's going to be 0 if we plugged in a positive 3. Okay, so 2 vertical asymptotes. Next, let's look at, for lack of a better terminology, let's look at their multiplicities. So again, look in the same place, what exponent is that factor raised to? So the 1 came from this factor. It's raised to the second power, so I'm going to go ahead and say it has a multiplicity of 2. The 3 came from the x minus 3 factor. I'm going to say that's raised to the first power, so I'm going to say multiplicity of 1. Now, in a similar fashion, what we just did over here with zeros or x-intercepts, these multiplicities tell us something about the graph. An even multiplicity says we stay on the same side of the x-axis, and we called it a touch over here for zeros or x-intercepts, but it's kind of the same concept. I'm going to say same side to indicate the same side of the x-axis. Whereas an odd multiplicity, I'm going to go ahead and say that means the opposite side of the x-axis. Kind of like when we say cross with our zeros, that means you cross to the other side of the x-axis or the opposite side. All right, finally, let's collect the information about the horizontal asymptote if we have one. So how we get this is we compare degrees of numerator and denominator. So for our numerator, it's going to have a degree. We're going to locate this by adding together the multiplicities. So you can kind of visualize if you had 2 copies of this factor and 1 copy of this other factor, we're going to have a total of 3 copies of x multiplied together. Or if you add together those multiplicities, 2 plus 1, we're going to get to that degree 3 as well. And for our denominator, very similarly, this also is going to be degree 3. Again, you can kind of think, add these two and the other multiplicity of 1, that adds up to degree 3. So when the degrees are the same, our rule says that y is equal to the ratio of leading coefficients. So we kind of have to visualize, if we don't want to multiply this all out, if we multiplied 2 copies of x and another copy of x together, we get 1x cubed. So the leading coefficient there would be a 1 for our numerator. And it's kind of similar for our denominator, except for this 2 that's hanging out in front of all of these sets of parentheses. That if you had 2 copies of this x and 1 more copy of x, you get to your x cubed. Now those would have a 1 out in front of them, but this 2 is going to be multiplied by whatever that result is. So they're going to have a leading coefficient of 2. So y equals the ratio of leading coefficients. Y is going to equal 1 over 2. That means we're going to have a horizontal asymptote at y equals 1/2. All right, next, let's put all this information together, just kind of include it in our graph. Then we'll talk through how to make sense of all of it. Okay, so we have a y-intercept at 1.3. So between 1 and 2, a little bit closer to 1. We have x-intercepts at -2 and +2. So I'm going to go ahead and include those on our graph. So -2 and +2 for our x-intercepts are zeros. Vertical asymptotes at 1 and 3. So I'm going to indicate these with vertical dashed lines. So 1 and 3. And then finally, we want to include our horizontal asymptote. And this is where the graph is going to get close to at the extremes, like way off to the left and way off to the right. That's supposed to be at 1/2. So I'll do my best on sketching the horizontal dashed line going across here at y equals 1/2. Okay, so where I would begin on my graphing on this, now that I've included all the information that we found, what I'm going to do is I'm going to start at my y-intercept because it's not on the x-axis. Now we're not allowed to cross vertical asymptotes because there's not a point on the graph. Those values of x would make the denominator equal 0. So we don't get a point on a vertical asymptote, so we can't cross a vertical asymptote. But let's start at our y-intercept and think to ourselves, if we move to the right-hand side, we're going to get to this vertical asymptote pretty quickly. And we have to make a decision. Either we go up when we get there, or we go down when we get there. The choice is actually pretty obvious on this. What I mean by that is, if I look at my x-axis, I didn't indicate any x-intercepts on the x-axis in this portion of the number line between our y-intercept and this vertical asymptote. So there's no gateway or a door or anywhere to go through the x-axis, or else there would be an x-intercept. So we're really limited. What's going to happen is we have to go up when we get to this vertical asymptote. So starting at our y-intercept, I'm going to go up when I get to this vertical asymptote. Let's also think if I move to the left-hand side. Well, the next thing I need to get to is this x-axis, the x-intercept. So I'm just going to kind of sketch it down from the y-intercept to this next point that I know has to be on my graph. From here, let's look at our directions. This is at -2. We had an x-intercept or 0. We were told we had to touch because of that multiplicity. So what we mean by that is we stay on the same side of the x-axis and come back up. Now at the extreme, as we keep sketching out further to the left, we know that we have to get close to a horizontal asymptote. So we don't know exactly how high up this goes, but we do know that at the extreme out here, we're going to get closer to the horizontal asymptote, that dashed line going across here at 1/2. All right, next, and this tends to be the more challenging part to students, is let's continue on from where we have this vertical asymptote at 1. Let's move to the other side of this. On the other side of that vertical asymptote at 1, notice down here our directions were with a multiplicity of 2, we want to stay on the same side of the x-axis. So what that means as we're drawing this graph is we either have a choice, we come in from the top, or we start at the bottom. Now because our directions were start at the same side, what that's going to tell us is we start at the top on the same side of the x-axis as where we finished up on the left-hand side. So this side went up, this is going to start at the top as well. Next, we want to get down to our x-intercept. At that x-intercept, at +2, our directions where we were supposed to cross the x-axis. So I'm going to cross the x-axis. And when I get to this next vertical asymptote at 3, I don't have many choices. I don't have another x-intercept in between here, so it's like solid wall. So when I get here, I'm going to just have to keep following it down to -infinity. All right, now that I've taken care of that, let's look on the other side of this vertical asymptote at 3. Vertical asymptote at 3 had an odd multiplicity, so we said we wanted to start on the opposite side of the x-axis. So since this was at the bottom, I'm going to start at the top. All right, no more x-intercepts to approach down here. So as we follow out to the right-hand side at the extreme here, we want to get close to that horizontal asymptote. You always get close to these horizontal asymptotes. This one's going to be at this dashed line at x or y equals 1/2. All right, so the most confusing part, and I think the most new part to most of us, is which side of the vertical asymptotes we start on. So just follow these directions as far as same side or opposite side based on the multiplicities. Put all the information on there and just take your time on graphing these. Don't cross the x-axis if you don't have an x-intercept. Yep, hope this helps. Good luck on graphing rational functions.